Welcome to our panel on social science and data science. I'm John Kropko. I'm a new faculty member at the School of Data Science, and my background is I've got my PhD in political science. So I came to data science from the social sciences. So that intersection is something that occupies most of my brain most of the time. I want to introduce our two amazing panelists, and we're all going to project as much as we can, like we're in front of an undergrad class of 200 students, because we've got this busy cafe right over here. So if at any point you can't hear us, please raise your hand and say, speak up. Okay, we want to be heard. First we have Professor Inez Levine, who is an associate professor of political science from the University of California, Irvine. Professor Levine's research is on computational survey methodology. She studies elections and public opinion, and she also studies the application of machine learning to problems in political science. She's published in a number of great journals on applied statistics and research methodology in political science. Our second panelist is Professor Hudson Golino, an assistant professor from the psychology department here at the University of Virginia. His focus is on quantitative psychology, psychometrics, and applying machine learning to different fields, psychology, health, education. He's developing a new research methodology called Exploratory graph analysis to help with measurement of social concepts from multidimensional data. He's the author of the first book written in Portuguese on Roche models, so that's awesome. If you have a copy of his book, he'll be signing right after the talk. Both of our panelists are currently doing research on the application of machine learning to social science. Both of them are have also published work in open access journals, which is something we care a lot about in the School of Data Science. And so the goal of the panel is to explore what is this intersection between social science and data science, and what can the School of Data Science learn or take away from this panel, from our interactions with social sciences? How can we develop as a field that contributes to the social sciences and understands it and provides value in that space? And so the way we're going to go is Professor Golino will first present on some of his research and how that fits in that intersection between social science and data science. Professor Levine is going to present some of her thoughts on the intersection between social science and data science. At that point, I've got a few questions for the two panelists, and then we'll open it up to the floor for any questions you guys have. Okay? So again, it's loud here, and so we'll do our best to project. But again, raise your hand if you want us to speak a bit louder. Happy to do so. And so with that, Professor Golino, would you talk about your research?
Okay, so good morning. I can't project as well as John, but I'll do my best. So when John invited me for this panel, I spent lots of time thinking about interesting things to show or talk. And I was really interested in showing some things we have been doing to improve the teaching and learning of data science for social scientists and psychologists and people for communication. But I decided not to present this and show you some interesting new things we have been doing in the past few years that may be very interesting for people that are interested in political science and social science in general. And I think it shows how we can use problems in social science to drive the development of quantitative methods to analyze data. Okay, so this is a very brief presentation, so I have around 10 minutes to present something. And so it will be super summarized. But the goal here is to show you one new method we have been developing in the past 24 hours to investigate the dynamics of topics in Twitter. So the issue we have is basically there is a huge amount of textual information that we have nowadays, right? Social media, it's a great source, but we also have newspapers, books, etc. So there is a huge amount of very valuable information hidden in text. And we can use text mining to help us extract this useful information or useful knowledge from text, and then help us understand how people work, how social systems changes, etc. So there are many interesting things we can do. One way to do that is to try to identify topics in text. So imagine we are reading newspapers, right? We can very easily classify newspapers or news articles into different categories because we are very good at identifying patterns. Machines are very good at identifying patterns if they have the correct tools to do that. One way we do in their data mining to extract topics from text is to use a set of models called latent topic models. Basically, the goal is to given a set of textual information or a collection of words, how are these words combining and in a meaningful way? So one of the most famous techniques was developed a few years ago by Blake. It's called latent rich allocation. And there are several improvements to the original algorithm. The goal is basically to identify topics in text, but with one specific characteristic. So this characteristic is the topics are not deterministic. So it means that one word can belong to more than one topic, which makes sense. But this generates another problem. So we have a trade-off between non-deterministic models and interpretability. Many of the applications of latent enriched allocation and other topic models, the interpretation is pretty difficult. So if you have data from social media, for example, sometimes the top 10 or 15 or 20% of words per topic are basically the same. So you can't make an interpretation. In education, it's different. In education, we can prompt students to write about a certain topic with certain rules, and then these techniques can be used to extract pretty clear clusters of words. But for more naturalistic textual data, that's a problematic thing. So we can solve this problem, or we can deal with this problem using deterministic models. So deterministic models basically will say, okay, so these groups of words here belongs to this topic. For example, let's say election. These other groups of words here talks about other things like food or beverages, for example. So these are more deterministic models, which means that one word can be in just one single cluster. So it helps with the interpretability, but we lose something about the dynamics of the word, the dynamics of language, right? So this is a decision that's hard to make. There is another characteristic of these text mining techniques that's called the bag of words. It's difficult to model the dynamics of textual content, right? So these topic models, they were developed as a way to identify latent clusters, but in general, they don't capture how things are changing over time. For example, if we have data from Twitter, very likely we have multiple posts for one single account over time. So if we use probabilistic or deterministic models, but we don't model this time information, we may lose something important that can help us understand what people are talking about or the dynamics of the communication, this kind of systems. So let me very briefly talk about this new thing we have been developing the past 24 hours, which is called the dynamical exploratory graph analysis. So basically in the past 3 years I have been working in an area that I call exploratory graph analysis, or EGA, which is basically the use of network models to do dimensionality assessment and reduction. So basically what we discovered in our simulation studies is that we can use network models to identify the number and the composition of simulated latent factors, and it's much more accurate than traditional factor analysis techniques, for example, principal component analysis, that's very well known in this area. But the problem is, EGA is a deterministic model that doesn't capture any dynamical things whatsoever, because although we are using probabilistic graphical models, we're not modeling time effects. So in the past few days, we have been discussing about a way to do that can capture this dynamical nature of communication. And we came up with this idea. We are calling it dynamical EJ. So it's a three-step approach. So the first step we take, we start with a collection of text. We extract the words from this text. And then we have a matrix with words and counts per observation. The observation can be one single individual over time or multiple individuals over time. For example, if we're extracting data from Twitter. The first step is we take this matrix and we time delay this matrix. So for each variable, basically what we do is, imagine we have one person and we have 13 posts. So we take the first column of the documentary matrix, which is a word. So we have 13 observations, 13 counts of that word in 13 different tweets. And what we do is we change this vector into a matrix that it contains information about time. So this is the time delay pattern. And then what we do is we do that for each collection of individuals we have. And then instead of having one vector across individuals, we will have matrices across individuals. So this is the way that we can time delay information. The second step is we use a technique called generalized local linear approximation to calculate the derivatives for this collection of matrices, which will give us information about how things are changing over time. And then we can column bind all these derivatives and have a data that's not anymore the observed counts of words, but the derivatives of the words per observation. So what we're doing is we're combining text mining with dynamics of changing of words over time. And then the last step, we use network models for discovering the cluster of these derivatives. So okay, so this is very briefly the description of the technique. So let me show you one interesting example. So as you know, the Senate has been investigating the influence of the Internet Research Agency from Russia in the 2016 elections. And they identified several accounts linked to this IRA agency in Russia. And some two researchers living in Warren, they extracted all information from all these tweets accounts and they released it online so we can analyze it. So I took a very small sample from these tweets. So the total amount of tweets we have is around almost 1 million tweets. So I took a sample of 63,000 just to show you one example here. And they labeled each account according to the intelligence operation. So some accounts, the goal was to post right-wing things, and other accounts left-wing things. So things that are interesting for people that are in the right spectrum of politics, things that they think is interesting for people that are in the left wing of politics. And then what we did was we used text mining to extract the words, and then we used dynamical EGA to identify the topics first for each group, left wing, right wing, and then we calculated the scores for each cluster, and these scores we used the dynamical EGA. So we first identify topics, then we calculate scores for each topic, and then we see how the topics are changing over time for different groups of Twitter accounts. And this is what we discovered. So this is the result of the dynamical EGA for the left-wing accounts. So basically we identified, so the clusters are changing together in 3 different directions. So one is is clusters that are related to social commotion things. Another one is clusters related to information to fight racism. And another one is a group of clusters that are talking about police violence and brutality. That's for the left-wing trolls. For the right-wing trolls, we identified clusters that are related to politics, particularly cluster related to information about Trump in the White House, about the right-wing movement here in the US, or about right-wing politics and information about right-wing politics, and also clusters related to fake news and about speech liberty in the Charlottesville thing that happened in 2017 that you all know. So this is so the clusters are changing together, and we can cluster. These clusters are changing together, and that's what we obtain. So basically, in summary, this seems to be an interesting way to take textual information, analyze content, and see how the content are changing over time. That can give us the dynamics of the communication. This communication can be naturalistic, or in this case, can be just an intelligence operation. And this intelligence operation was created by someone or a group of people that had hypotheses about content that should be published in Twitter to influence the debate here in the United States since 2014 up to the elections in 2016. And as we can see here, the topics and the dynamics of changing of these topics make sense if we look back at what happened since the elections and this our online environment and our social environment during that time. So basically what we can do with this technique here is to basically uncover strategies for intelligence operations online. So if we have some idea or some hypothesis on how to group Twitter accounts, we can identify different patterns for different Twitter accounts, as we did here. So this can be an interesting way to analyze this kind of information. The next steps is, so I have a package that's published, is a package in R, so it's on-prem. The name is EJNet. It can do dimensionality reduction using network models, but this new dynamical model is something that we are still working on. So we started working on this like yesterday, literally. And thank you very much for your attention.
Thank you very much. Next, Professor Levine will give us some thoughts about growing research in the intersection of political science and data science.
So what I would like to do is, I would like to talk a little bit about the role of social scientists in data science. And the reason why I want to do that is because many times when people think about data science, they think about computer science and kind of everything that computer scientists are doing to help us sort of collect these massive data sets, store this data, help us process this data, and so on. And sometimes people are not very clear about, well, but what is exactly that social scientists can contribute to data science? Okay? So I would like to talk a little bit about that, and I will focus on 3 different types of challenges facing data scientists, and when it comes to each type of challenge, kind of how it is that social scientists might help us sort of figure out solutions, okay, to some of these issues. So first of all, starting with technical challenges. So once we've collected kind of massive data, say massive data about people's online behavior, for instance, about behavior in social media and so on, we cannot just analyze those data naively. So we know that big data, okay, has limitations, okay, have limitations. So we know that there are problems with representation. Not all groups in the populations that we are interested in are equally fully covered or equally represented. It also happens that sometimes there are problems with sample selection. So if we're looking at data from individuals, sometimes the people who end up being included in these data sets are different from the people who are not included in these samples. And sometimes there are also measurement issues where the indicators that the concepts that we are interested in measuring. And here, so unfortunately, statisticians and applied researchers have developed over decades already methods that can be used to deal with some of these different problems. And here social scientists can help because we have experience applying these methods to deal with similar problems in conventional data sets. They say for people who work with survey research, it's an everyday task to kind of use weighting approaches to deal with problems of lack of representativeness. We also have experience in terms of methods for dealing with sample selection, with measurement problems, and so on. Okay? So definitely when it comes to kind of some of these particular technical difficulties, the social scientists have skills that can be useful to kind of help us figure out how to deal with these limitations of big data. And there's a second type of technical challenge, which is something I'm very interested in. I'm currently writing a paper on that topic that has to do with, well, how can we ensure that if we are going to use algorithms to automatize decisions, okay? So suppose that we're going to use algorithms to automatically decide if we're going to hire someone, if we're going to give a loan to someone, if we're going to, say, grant bail to someone who's being investigated for a crime, and so on. So if we're going to try to make those decisions automatically, or at least use algorithms to inform the decision-making process, so what can we do to ensure that the algorithms do not inherit biases that characterize human judgment? So why would algorithms do that? Why would algorithms behave in a human-like way and replicate those type of biases? Well, that can happen because if the data that we use to train our algorithms contain biases, then the algorithms are going to sort of learn about those biases and are going to sort of replicate them in the advice that they generate. Okay? And computer scientists have been working already in developing methods not just for training algorithms, for teaching them how to learn from past experiences of human beings, but also to teach algorithms how to forget undesirable behavior. So the idea is that they're coming up with methods for what can we do to use training data that we know contains biases, use it to train the algorithm, but at the same time teach the algorithm to only learn some part of the behavior, but not the part of the behavior that is not desirable. Okay? And so I believe that we should be paying more attention to that particular part of the computer science literature. So here is a part of one particular area where I feel as if social scientists still need to sort of pay more attention to what other scientists are doing, because so far we've been focusing more on sort of learning algorithms and not so much on kind of how we deal with this type of situation in particular. Okay, so then when it comes to ethical challenges, probably the main challenge has to do with much of this big data, okay, that we're starting to use these days, pertains to data from individuals, generated by individuals themselves as they go through their day-to-day lives, okay, as they use the internet and so on. And they might do so without awareness of how that data is going to be used. And without awareness of the fact that they are being observed, they might have some expectation that some of what they are doing is being recorded, but they probably are not aware of in how much detail is being recorded. And probably also they don't have awareness of the implications that may have for their future, whether they're going to get a job, or they might get a loan. So here is when it comes to this type of challenge, I think that social scientists have much to offer, because it is part of our conventional research practice to take steps to protect the subject of our research. Okay? We already have a framework that is available to us that we can use to ensure that we protect people's privacy and anonymity, that we show respect to research participants. Respect includes, for example, providing people with information about what's going on and about the implications of their actions in the context of our studies. Also preventing harm to our participants and other protections that we typically provide. Okay, so one thing that we can do is to kind of perhaps this framework can be both adopted and adapted to deal with some of the ethical challenges associated with big data. Okay? So then when it comes to analytical challenges, if we're going to be using this data to learn about and test theories and make predictions about the way people are going to behave, then we need models of human behavior. Okay? And then, of course, we need social scientists to come up with theories that will help us understand kind of how the mind works, how societies react to changes in settings, and so on. So definitely, if we're going to be using data to kind of better understand people, then we need social scientists. So we need their theories, we need their substantive knowledge, okay, of the different topics, and we need their technical skills, okay, that they already have and that we've been using to deal with kind of other types of kind of more traditional forms of data. Yeah, and that's it. There is another challenge that is both, that is kind of, it's hard to classify in terms of if it's ethical, analytical, or technical. That has to do with, but where I feel as if social scientists can help us understand the nature of this challenge. What's going to happen once people, okay, once we're generating all of this data, become aware of the implications of the behavior. So we as social scientists, we know that when people become aware that they are being monitored or observed, that changes their behavior. Okay? So that's known as the effect. Okay? And so perhaps if the industry, okay, took serious steps to protect people's privacy and confidentiality and to kind of convince people that they're kind of, and did so in a way where customers are sort of adequately informed, such that they will trust that they are indeed being protected, then maybe they won't behave in that manner and they will continue to use and to behave sincerely. By sincerely, I mean non-strategically. Okay? And so social scientists may be able to kind of provide some advice on kind of what those steps may be. Why? Because in the context also of conventional research that we conduct as social scientists, those are things that we already worry about. Okay? So when we conduct survey research and survey experiments, for example, we know that if we say word our questions in such a way that our participants realize that they are being subject to experimentation, that might alter their behavior, okay? Or if we're asking questions on sensitive topics, okay, people might become concerned that then their identities will be matched to whatever they respond, and in reaction to that, they might start providing responses to our questions that are not sincere. Okay? And so, survey researchers have come up with all sort of approaches that we use to kind of word questions and design experiments such that people will trust that their anonymity is preserved and will therefore provide sincere responses to our questions. Okay? So here is that is another area where I feel as if social scientists might be able to use some of that experience to inform how it is that we might convince the public and treat the public such that they won't engage in this form of strategic interaction or kind of try to sort of manipulate the system, right? So this is all I wanted to say during the introductory part at least. So if we are going to be using big data to learn about how human beings behave, then we definitely need social scientists. There's much that we can contribute and ways in which we can help deal with all of these different challenges.
Thank you very much. I've got a few questions for the panelists. I'd like to go through those and then open the floor up after those for questions from you guys. So the first question is for Professor Levine. 5 years ago, I didn't know what data science was. I had no idea. Like, this is a brand new thing, right? And so here at UVA, a little more than 5 years ago is when the Data Science Institute started, but back then it was called the Big Data Center, I think. That's right. Anyway, 5 years ago was the origin, right? And in those 5 years, the growth of the Data Science Institute and now the School of Data Science is just like unbelievable, right? So that's the story at UVA, but like nationwide, like data science is becoming like a big thing. How has the growth and impact of data science already changed the social sciences? And is there like new research or new breakthroughs in old literatures that have occurred as a result of data science?
So I believe that when it comes to how data science has changed the social sciences, so it has opened up two types of sort of opportunities, sort of data opportunities. So now we have both larger data sets and access to new types of data. So data that were maybe some of it available before, but maybe we didn't have the tools that we needed to analyze them. So when we think about new types of data, you can think about say, sort of materials that now we can read as data. Okay, say text and media, including sound and video, social network data, social media data, and so on, geographic data. So now we have new forms of data, and we have the computational resources that are necessary to analyze those data. Okay? So that's one big change. And then something else is that now the size of the data sets that we have access to have also changed. Okay? So many of these data sets are massive in size. And massive data sets allow us to create some sort of analytical opportunities. Say, when you have small data sets, and say suppose that you want to make predictions about a certain outcome, okay, using information contained on a small data. So I'm going to refer to the information in the small data set as sort of predictors. Okay? So you want to use predictors in the small data set to learn about a certain outcome or dependent variable. Okay? When the data set is small, you need to make some assumptions about how predictors relate to the outcome. Okay? So one example are sort of functional assumptions, like the ones that you make when people estimate sort of standard regression models. Okay? When you have massive data sets, we don't need to make those sorts of functional assumptions because we can learn from the data, okay, what the shape of how the shape of the relationship looks like. Okay? Rather than assuming, say that there is some sort of linear or quasi-linear relationship between predictors and the outcome, we can learn about the shape of that relationship from the data. Okay? So now we can make fewer assumptions. And sometimes those relationships between predictors and outcomes can be very complex and can involve deep interactions. Okay, say deep interactions has to do with, say, how one predictor, say if you want to think about how some individual attribute, how some attribute of a person, for example, relates to their credit risk. Okay? So the relationship between attribute A and credit risk may depend on other attributes of the person. Okay? Attributes B, C, and so forth. Okay? So there might be interactions between the predictors. Okay? So the relationship between a certain predictor and the outcome is not constant. It depends on the level of everything else. Okay? So when we have these massive data sets, we can learn about all of these sort of interactions, which are things that we couldn't do before. Okay? And because we can learn about kind of these deep interactions, we can also see, for example, how quantities of interest vary over subgroups. Okay? So for example, suppose that you are carrying out experimental research, okay? And you want to see how the effect of a certain intervention, okay, varies over subgroups in your sample. Okay? So when you can estimate these models are very flexible and don't impose functional assumptions, then you are better able to learn about sort of those heterogeneities in that particular quantity of interest. Okay? So that's one important sort of way in which data science has changed social science. Okay? We're better able to learn about heterogeneities in the data. Okay? And then something else that we can do is sometimes we're used to learning about what are called latent concepts. Okay? So we want to learn about characteristics of our observations, and when I mean observations, I'm talking about our data sets refer to individuals, to people, but they can also refer to materials generated by people, like text, like speeches, for example. Okay? So each observation in our data set could be a speech, for example, or generated by a particular person. Okay? So you might be interested in learning about some attribute of those observations that is not directly observable, like the topic of the speech, like the tone of the speech. And so data science allows us to sort of, and some machine learning techniques, unsupervised techniques in particular, allow us to learn about some of these latent features that are not directly observable by combining information contained over multiple columns in our data set. Okay, so we are better able, relative to what we were before, to sort of learn about latent concepts. And so I believe that those are kind of the most important things. Kind of we have data opportunities. Okay, so once again, we have access to types of data that we didn't have access before, or there are materials that we could access before, but we were not able to process them, and we didn't have the technology to do that. And now we also have the computational equipment and resources that we need to analyze those sort of data. Okay? So we have both. So data science has offered both data and technological opportunities to social science. Yes.
Thank you. My next question is for Professor Golino. So going in the other direction, in her introductory comments, Professor Levine talked a little bit about how the social sciences can influence data science in the future. I'd like to just get your thoughts on the same question. And then with that in mind, do you have a vision for how social scientists and data scientists can collaborate in the future?
Well, I think what Ines just pointed is very accurate. And one thing that I think it's not necessarily a direct consequence of data science for social sciences per se, but the characteristic of social science is that I think some years ago, at least in psychology, I'm not sure in other areas, we had this huge hope that new types of data, massive data, would solve our problems in terms of the substantive questions we have about how people work, think, and operate and change. Didn't happen. And it didn't happen for one single reason. Techniques, so methodology to analyze data and volume of data alone can't do the job. Because we need good theory. Because how we obtain data, of course, we can obtain data automatically using smartphone devices or social or human interactions. But the usual way to collect data, even though we can collect a large amount of data using smartphones, depends on at least hypothetical constructs and theory. So the quality of the data we're collecting improved quantitatively, not necessarily qualitatively. And we need good theory. And I think a combination of methodological development, new types of data and quantity of data, plus development in the area, in the theory field, will really improve at least psychology and I believe all other areas. One example that we made, I think there is a huge connection between astronomy and social sciences, astronomy and psychology. So they deal with non-observable things all the time. So they have physics in general. They deal with people deal with latent constructs all the time. They have massive amounts of data, especially in astronomy and particle physics as well. But they have very good theory, testable theories, right? Although you can't do an experiment in astronomy, and we can do experiments with humans, but they have very good theoretical models that can be tested using high-quality data. And at least in psychology, we have at best a handful of good models on how people think, operate, and behavior and change. And so I think we really need to improve our theories to make a better use of methods and data. And I haven't seen that happen, at least in psychology so far. But I believe it will. I have this.
I've got a couple more questions, but at this point, I think I'd like to open it up to the floor. If any of you guys have any questions.
How has ethics and hierarchy impacted the ability to use big data?
What do you mean by the ability to use big data?
So there's a lot of questions about the collection of data through Facebook and Google, and those data sets that they often probably like the first data set are collected without like proper user consent. And I'm wondering how that affects the IRB process of getting studies cleared, or that's not a problem.
I would say that in the context of academic research, new forms of data are being treated in the same way as conventional forms of data. And some of these challenges that we're talking about are not less severe when it comes to conventional forms of data. Say, if you are just interviewing people, or you're conducting survey research on sensitive topics, the ethical challenges are as big as the ones that you face when you collect kind of, say, social media data. So the way IRB goes about it is the same way as we need processes kind of other forms of IRB application. Okay? We want to make sure that you took steps to preserve people's privacy and confidentiality, that everyone in the research team has the adequate training, that you are, say, that people are kind of, so they will evaluate whether there is a need for people to provide their consent and so forth. So they will go over all the standard requirements the same way that as they would go with other forms of research. I believe that the main ethical challenges, but that's my impression, have to do with how industry is using this data. How people who don't have to go through IRB are using this data. And if we have to go through IRB, and a good IRB, we try to make sure that people have all the necessary protections. But people, let's say, in organizations, agencies, companies who are using this data and don't need this and don't have this sort of supervision, I believe that there is where the main risks lie.
Yeah.
Okay. Thanks for coming today. Mason, I'm a data scientist at CarMax. Last week, I was still a data scientist in the hospital just down the street. So we had a lot of medical questions come along our way, and one of the bigger ones that we weren't necessarily asked, but I think kind of like hits both of y'all's areas I'll talk about today, the clustering and the potential bias. Like, we've thought about trying to project, say, diagnoses, but kind of had a realization that we don't really know the person had this, we just know the doctor labeled them with that diagnosis based on this cluster of symptoms. And I was curious if you all had any thoughts about like any similarities in your research about that sort of like, here's a cluster of symptoms and someone this label on it, or like we don't really know that they had this, we just know what the expert labeled them as having. And then how do you really do an analysis on that and try to train it, or how do you predict that? You don't have ground truth, you just have what the doctor said.
Well, that's a very complicated question, actually, because so if you want the easy answer is, well, the ground truth is take the symptoms and see what's the most likely diagnosis based on that. It doesn't mean it's right, and it doesn't mean it will be the same in 10 years. It's based on actual knowledge, agreement between experts, and availability of data. So my approach to that is, if you want to have a more complicated solution, but in my view it's better because it can be better control for uncertainty, is always use raw data, not use labeled data. So for example, let's take the example of mental health, for example. So although there is an agreement in the medical areas on what is a generalized depression, for example, or general depression, we quite don't know what is actually depression. Because we know some behavior symptoms, We know what people talk about, how they describe themselves when they're in this state. But we have no idea about the neurological underpinnings, about the sociological underpinnings as well, about the movement, how movement changes. And medical diagnosis nowadays, although it's much improved than 10 years ago or 20 years ago, we still use the same information. We use self-reported information about how people are feeling. Maybe we can have some biomarkers at best, but we don't collect other types of data, for example, movement, right? So if you have more data, or at least if you have some data available about a person or about a group of people, what you can try to do is try to find clusters that are meaningful given the data that you have, and then make an interpretation based on the empirical results, and then you combine this with the medical label, for example. But I don't think it will actually solve the problem. So to solve the problem, we need to advance science and advance medicine to have more precise diagnosis.
But then something that can be done is, suppose that if the data set is large enough, okay, you can see you can get a sense of for a given set of symptoms how much uncertainty there is about the diagnosis. So if you see that the same set of symptoms tends to receive many different labels by different physicians, okay, that tells you that there's a lot of uncertainty. But then for other set of symptoms, you might see that their consistency, that the diagnosis tends to be consistent across physicians or across cases. So depending on the characteristics of your data set, if it is large enough, if you have enough cases where similar symptoms are seen, then you at least can get a sense of the uncertainty. So if there's a lot of uncertainty, it's as you were saying, it's like unless you advance medicine in order to sort of narrow down the diagnostic, even a set of symptoms, or maybe you can add more columns to your data set, such that then you will have more information on the cases that will allow you to sort of zero in on a diagnosis. But if you keep the data constant, and you at least can get a sense of the uncertainty that there is in the diagnosis, and that's valuable, right?
Other questions?
So, obviously the central focus of this event is research, but from my perspective, it's impossible to not also think about teaching, and particularly if we're interested in being more inclusive of social science when we're talking about data science. And so I was hoping we could talk a little bit about the implications for the shift towards data science in the social sciences in terms of how we teach and how we train the next generation of researchers. Have you, I assume that you've had to think about that and navigate that in your respective disciplines. Can you just talk a little bit about that experience? That'd be great.
Yeah, so that's the thing I really like the most. Although we have much more complicated models and techniques and data sets to deal with, in my view, it's we also have a new mindset, a new mind frame. And in this new mind frame, first of all, people can learn by themselves. If you have an internet connection and an okay notebook, you can go online and find thousands of very good online free courses, and you can learn basically everything that you need. So you don't need a formal environment anymore, although a formal environment helps a lot, but if you want to learn, you can just go online. So this is the new mind frame, right? So it impacted positively because people, especially students, they are more inclined to learn by themselves, even when they have a formal environment. So they like more the idea of having real problems to solve, and then they have someone they can ask good questions, and then that can guide them in basic steps, and then they can just use the data in the problems that they want to solve using the data to learn about techniques and that. That's much better. So let me give you just one example to summarize this. I teach two different classes. I teach one graduate class, it's Introduction to Quantitative Methods for Graduate Students in Psychology, which is mandatory for all PhD students. And I teach an elective, which is Introduction to Data Mining and Machine Learning. That's open for advanced senior undergrads and graduate students. The level of motivation in both classes are completely different. The students that go and they want to learn about data mining and machine learning, the motivation is very high. Although the content itself is much more difficult, they perform better. The difference is actually the motivation, because they want to learn something that they know or they have a feeling will be extremely useful in their profession, or because they think it's very cool and they want to learn that, right? In the mandatory class, it's also very important. It's also will impact their careers, their scientists, but the level of motivation is not the same. Why? Because first of all, they can't choose, and the second of all, they are not going to the class with the mind frame of I can learn this by myself. I'm here because I want to have a basic structure, and then I can continue by myself. So that makes all the difference. But also it impacts in the way we teach. Traditional lectures doesn't work for data science. You really need to have hands-on stuff and active learning environments. Otherwise, it's much more complicated.
Yeah.
So about this, especially with this topic, the pushbacks that we are getting in social sciences about privacy, and we are intentionally distorting this raw data, not only not adding columns, removing some columns, making the problem harder for us, then the solution will be less precise at the end. Is there any way to systematically doing this in a way that everybody says something in a way that can be reproducible because the data is not that data, it's anonymized, for example, it's a network. So any insight into this?
What do you mean when you say that we have to remove columns? So
for example, if it's about some sensitive things, if we are collecting some sexual partnering, sexual disease network, it's not a sociocentric network anymore, it's an egocentric. We cannot connect these egocentric networks together. It's getting harder and harder, and then reproduction will be harder too. It's like, not only, the removing bias will be harder, it's like everything gets harder. And it's not like everything gets better with the period, like data collection. Sometimes we are getting pushbacks. It's like the initial data mapped to not good looking data in a way that other people can be happy. But still we can say something.
That's a really important question. Because just because so the reason why people are sometimes not allowed to sort of see certain type of information about the people in their research is just because you want to protect those people and make sure they are, not just protect the confidentiality of the information, but make sure that people are not going to be treated at a disadvantage because of that characteristic. Okay? And that's, if you're using that data to make a decision that's relevant to that person, then you don't want that decision to be influenced by that. But then the problem is that sometimes you have other information in the data set that might correlate with that characteristic. So people might be able to learn to some extent about that thing that they are not measuring, that they are not directly seeing from other information in the data. And then they might use those other proxies to indeed discriminate, say, against people. But since you don't directly observe the attribute, there's no transparency. So it's hard to show that people are indeed discriminating. Okay? So it's very tricky. I don't think I have when it comes to the thing where I would say we need to be careful is when you say our results are less precise because we are not allowed to use that information. Well, sometimes the reason why results become less precise is because and precise in general is in reference to something, right? Meaning so the research that I'm currently working on, which is the one about what happens if you're training an algorithm based on past human experiences that involve discrimination. Okay? Say if you take some of that training data and you try to say to remove the bias in the previous decisions, okay? Then when you take steps to remove the bias, then the algorithm that generates advice without bias will generate advice that does a poor job at fitting the past decisions. Because the new advice doesn't involve discrimination, but the old advice did. So when you start changing things such that the outcomes are more fair, you will start doing an increasingly worse job in terms of fitting the past decisions, but for a good reason, because you don't want to perfectly fit the past decisions because they involve discrimination. So I think that we need to be careful with when we say, oh, our predictions are less precise. Sometimes precision is not the only goal if you want to ensure fair outcomes.
I meant like not individualized solution.
So
We are forced to say kind of blanket statements sometimes. So something like that, like if it's a network, we cannot go to each person. It's better for you to do this. We should say like this cluster of people. It's better to deal with a cluster instead of an individual, which is very important in education when we are intervening for a student that is getting close to dropout. We want to find that person ahead of time. That's something that is discussed in the education panel. But something like that, which
Well, I think it depends a little bit on the data you have. So for example, for individualized things, if you have individual level information over time, for example, you can do that without the need to disclosure information that will allow the identification of the person, the participant in this research, for example. So for example, we have a huge interesting line of research in clinical psychology that's basically trying to not just understand, but make interventions as people behave. So there is this huge area called ambulatory assessment. One subfield of ambulatory assessment is a way to collect data that is ecologically valid. So instead of asking people to answer these questionnaires in a lab or in their houses, you have smartphones, and then every X minutes in a day, you prompt people to answer questions or information or perform tests. And you do this for like months or years. So you can have very, very precise, intensive longitudinal measures for each individual. And then, for example, you can use a machine learning algorithm, for example, to learn what's the pattern of responses before the onset of a given disease. For example, before the onset of depression or generalized anxiety or a panic attack or something like that. But the problem is not that we need to remove information that can identify the person. The problem lies in the way we store data. Because right now, the traditional way of doing it is we have a data set and then we have a model that we use in that data set that will do something, right? So there is a very interesting project in the School of Data Science here, led by Professor Steve Volker, and he's proposing a new strategy to allow data modeling without access to actual data. So the goal is you have the data in a protected environment, a protected source or service, and then you have the model, and then you make the model travel to the data, and then you return just parameters of the model. And you can do this continuously until you have the optimization of some parameters, for example, that can ask important questions about what you're doing. So the idea is very similar to what happens with bank transactions, right? So not necessarily the financial system will have access to your individual information, but will have information about your data that can be used in a given model to make, for example, modeling, financial modeling, etc. So your data is in a secure system, but the model can travel freely. So nowadays, today, the most usual way of doing it is you need the data to be together with the model in the same computer environment. Otherwise, you can't do it. So with this shift, if what they are developing actually is implemented and it's working well, then you can basically use whatever information you want because you don't have any information sharing. The information is completely secure in an encrypted machine, for example, somewhere. And what is traveling, let's say, is model.
So that's our hour. It went by really fast. I'm sure you have more questions. If you do, Will you guys be around for a little bit? Answer some questions. Let's please thank the two panelists. This was an awesome.